Let's get ready to continue with this afternoon's sessions. Let's proceed with the roundtable Carbon-Free Energy Sources for the European Steel Industry. The transition toward low-carbon steel production is a cornerstone of Europe's broader industrial decarbonization strategy. At the heart of this transformation lies the assurance of dependable carbon-free energy sources, chiefly renewable electricity and clean hydrogen. As a steel producer, design and invest in the next generation of facilities, a pivotal question emerges. Will there be sufficient energy supply and infrastructures in place when these operations come online? This session will examine Europe's preparedness to meet these three future energy demands, featuring expert insights into renewable energy generation, hydrogen production, and establishing secure, efficient distribution networks. The sessions will be moderated by Dr. Susan Michalik. She is a full professor at the Technical University of Lebanon and chair of ferrous metallurgy. She also serves as chief scientific officer of the Metallurgical Competence Center K1 MET and head of the Christian Doppler Laboratory for Inclusion Metallurgy in Advanced Steelmaking. With a distinguished academic background and solid industrial experience, she is recognized internationally for her contributions to steelmaking research. She is a guest professor at the University of Science and Technology in Beijing. She has received as well multiple awards for her scientific work and serves on the board of the Austrian Society for Metallurgy and Materials. Please welcome Dr. Michalik.
Thank you.
Thank you. Let me ask you some questions before we start with the roundtable. As we all know, transitioning to carbon-free energy sources for the European steel industry is a monumental challenge. What are these essential aspects and which focal points will your panel address?
Yes, thank you very much. Good afternoon also from my side. And of course, as we already heard in the panel this morning, there are a lot of things to do. There are a lot of things to address, and it is still a journey to go. But it's a critical thing that we go this journey together and go forward. And the panel tries to address these different points from the energy side. Yeah? So you mentioned already renewable energy, clean hydrogen, all these things. When will it be available? Also the economic feasibility. We would like to discuss a little bit about that. Technological and regulatory framework, some technological innovations, and how to drive this development also from the energy sector forward.
Thank you. How do you see the roles of energy providers, steelmakers, and policymakers aligning to achieve this transformation?
I think it's a joint effort needed. So, of course, steelmakers are doing their investments, doing the homework which is needed, which needs towards the goals of 2030, 2050. But this cross-sectorial approach, putting together energy providers, steel industry, and of course, all stakeholders who are in the surroundings involved in the one or other direction is very important because the goals are set for the next years.
Let's know more about it. I yield the floor to you. Thank you very much.
Thank you very much. Yeah, ladies and gentlemen, for me it's a pleasure to moderate this carbon-free energy panel as a real metallurgist, let's say, and dealing with many questions we heard this morning from a research direction on a daily basis. And therefore, I don't want to waste any time to introduce you the panelists of today and who will join me on the podium now. The experts bring diverse perspectives from policy, industry, academia and technology. Please welcome with me Gregor Pavlec, Director, Regulatory and Market Intelligence, Hydrogen Europe, Christian Kulic, Global Market Executive Metals from Total Energies, Francisco Lavaron, Head of Energy Prospective, Iberdrola, Michaela O'Donoghue, Global Strategic Marketing Leader, Electrification Systems from GE Vernova, and Thomas Kienberger, Professor at the Technical University of Leoben for Energy Network Technology. Please give them all a warm applause. As the session in the morning will be also two parts, so we'll start with a short input presentation of each panelists, and then going into the discussions, question and answer sessions. Please also remember to submit your questions via the app. I will tick my phone when it's time to go in this direction. With that, don't want to stress your time further, and I would already ask Greg for your first input. Greg joined Hydrogen Europe in 2019 as a research, innovation and funding manager. They are already focusing on decarbonizing and coordinating funding initiative under the Horizon Europe framework. Since January 22, he served as the director of the intelligence unit, and before this, he accumulated 15 years of consulting experience, and so he can give us a perfect overview. The floor is yours, please.
Thank you. Thank you, and good afternoon, everyone, as well from my side. So again, the topic are different kind of energy vectors. Not surprising, I'm from Hydrogen Europe, so I will be focusing on hydrogen mostly. Just for those that don't know, Hydrogen Europe, we are an industry association based in Brussels, so focusing on advocacy and lobbying for the clean hydrogen sector, right? And the clean is important because we don't advocate for grey hydrogen consumption anywhere, only clean, but clean encompasses not only renewable, but also low carbon, pink, whatever color you can imagine, as long as the carbon intensity is low, is good enough for us. And we represent the whole value chain with more than 600 members at the moment. So I will start with that. I'm sure you all know that. That's an average-sized steel plant that if it would kind of switch to renewable hydrogen, those are roughly the amounts of renewable energy electrolyzer installed capacity that you would need. And so I don't want to go into details, but the point of that is that this is challenging enough already as it is, right? We are talking about 6 gigawatts of renewable electricity if we would be focusing only on solar energy as our main input, right? 4.5 gigawatts of electrolyzer capacity. We would be requiring storage of hydrogen that would be equivalent of 3,000 as much energy storage capacity as the largest battery electric storage site in Europe, right? Or in the world. Okay, you can optimize a lot of that because this is assuming you are sourcing electricity exclusively only from solar energy, right? That might be good in Spain, but you would mix with wind, you would mix probably also some grid electricity, and that can be optimized quite significantly, but as you can optimize as much as possible, you will still end up with gigawatt scale of required renewables, gigawatt scale of required electrolyzer, and we are talking about close to 10 billion euro of capex that would be required. So again, the point is that this is already quite challenging, and we should have regulatory framework that should facilitate that or enable that, make it as easy as possible. Unfortunately, that's exactly the opposite of what we have at the moment, because we have a number of regulations in Europe that are, for example, Renewable Energy Directive that requires you that as the moment you use hydrogen in an industrial application, 42% of that needs to be renewable, right? So that limits your possibility of using maybe low carbon hydrogen, pink hydrogen, whatever, for your still decarbonization, right? So that's already limiting somehow the options that you have. It's not good enough that your electricity is renewable, that renewable electricity needs to fulfill the condition of so-called additionality, right? So the renewable source needs to be built no longer than 3 years before the electrolyzer is put in operation. And that already also limits your supply of renewable electricity. Because when we talk about 6 gigawatts of renewables, and then you limit the possible pool of renewable assets that you can use to only new ones, that obviously increases the price of that electricity. But it's not only the time, it's also the fact that they cannot be subsidized. So any renewable asset that received any subsidy from the government is automatically ineligible to produce any renewable hydrogen from that electricity. It will be counted as grid electricity, right? The moment the asset is subsidized. And for offshore wind in Europe, that basically makes offshore wind almost completely useless from the point of view of being able to produce renewable hydrogen from it, right? And there are many other elements, like there is, for example, the need that from 2030, your renewable electricity production will have to be matched 1 hour to 1 hour with when you produce hydrogen. And when you have a intermittent variable energy source like renewables, and on the other end, fully inflexible demand for hydrogen from a steel plant, then you can see that that creates a problem because you need to start investing into energy storage and so forth, right? And that adds cost again and again, again. So all those points, I mean, you can see that there is some sense of it. We should prioritize maybe renewable electricity. That's fully understood. But if you add all of those elements together, you are adding a lot of costs on top of it, right? And when it comes to energy storage in particular, I mean, okay, as I showed you, you need a lot of it. You can optimize it. You can mix grid electricity. But as long as you are using intermittent renewable electricity, you're always going to be needing some storage. Maybe you can reduce the demand for, maybe you don't need to have, 10 days of storage. Maybe you can only use 5 days of storage or even 1 day of storage. But with those huge demand for hydrogen that we are talking about for a steel plant, that's how 1 day of storage would look like. That's 1 day of hydrogen storage for a steel plant of that size that I showed before. Okay, this is supposed to be a joke, but it is a joke, but it also isn't a joke, because it's an AI-generated picture that would show you how much actual storage you would need for 1 day. But the point still is that this would add cost. So all regulatory demands that would force the renewable hydrogen producer or the user, steel plant in this case, to invest in additional storage, obviously will increase cost of it. And that's exactly the opposite of you would like to have the regulatory framework in place. There are other points. I mean, you can talk about being able to use other electricity sources, which is not possible, in the regulatory framework in the EU currently. Either you use renewable electricity or you use grid electricity. That's the only sources you can count when you calculate the carbon intensity of hydrogen. Nuclear electricity, just grid electricity. You can have, CCS with natural gas, that's grid electricity. No other source is recognized but renewable. Any other source is grid electricity. So there are all those issues that create those problems and make hydrogen production more kind of expensive than it needs to be. Because that temporal correlation I just said, that could be dealt with storage, but that could also be dealt by having another source, maybe a bit more reliant nuclear power plant as a backup. But since the regulatory framework makes you, kind of disallows you to do that, then you need to invest in storage and you add cost, right? So that's the point. There is, I think, some issue with the units. Doesn't really matter when it comes to the overall prices. So what the graph shows is the overall cost of steel produced from H2DRI and hydrogen cost that would be needed for that steel plant to break even with conventional steel production. And in order to do that with renewable hydrogen, you would have the hydrogen cost delivered at the steel plant at 2 euros per kilogram. And that means delivered, so not produced at 2 euros per kilogram, but delivered. So including all that storage, maybe pipelines along the way and so forth. So that's a huge challenge, and I don't need to tell anyone in this room that this is currently not possible in Europe, right? To reach those kind of costs. And that regulatory framework, which I described just before, makes it even more difficult than it used to be, and that's why I think it's important to say that we need to change that regulatory framework. However, we also need to be honest that even if all those regulatory barriers would be removed, we will reduce the cost of renewable hydrogen production in Europe, but whether we would reach 2 euros per kilogram, I probably say that even with those changes, it's not feasible at the moment. In Spain, where we are here, the recent hydrogen bank auction has kind of showed that the hydrogen production cost in Spain are around 5 euros per kilogram, right? So that's significantly above that break-even point. However, what I also wanted to say is that if we would increase or add a certain green premium on top of steel price, in this case, in this example, 25%. So if there would be an off-taker willing to pay 25% green steel premium on top of the steel, that break-even point for the hydrogen delivery would increase from 2 to 5 euros per kilogram. So within the realms of possibility of that being produced in Europe at the moment, right? So that's the second point that I wanted to make, so that we need to focus on the regulatory framework. We need to streamline that as much as possible to enable as cheap as possible production of hydrogen in Europe. However, even with that, I think we need to be realistic about how much we can bring the renewable hydrogen production costs in Europe, and therefore we should also work on ways of stimulating demand for products that would be using those, that steel or products produced from green, clean, or whatever steel, right? That can be either lead markets in automotive. I mean, it was mentioned at the earlier panel that there are some producers of vehicles that are willing to pay a premium on a car because a BMW produced from a green steel costs 200 euros more per vehicle, right? So that's something completely negligible from a customer point of view. And there are some other niche markets like that, that maybe it's possible to create a demand either through obligations or maybe through incentives to have that, because otherwise my point is that costs alone will make it extremely challenging to have a market for green steel in Europe at the current regulatory framework. Thank you.
Yeah, thank you very much for this honest introduction and already putting some very important aspects on the table for our ongoing and further discussion. Let me introduce the second speaker, Christian Kulic, who is already not the first time at the Energy Panel, so well-owned expert already for this event. And he started his career at Total Energies already in 2003, holding several positions in corporate strategy, business development, and sustainable development. And in 2022, he was then appointed the Global Marketing Executive of Total Energies Solution Division. Christian, the floor is yours.
Thank you very much, Suzanne, for the intro. Good afternoon, everyone. I want to thank, to start with, the AIST Organizing Committee and José Noldin, of course, for the kind invitation, because it's always very good to be back within the steel community. It's an honor to be here and to share some insights, some expertise about low carbon energies, about renewable electricity, especially in the current turmoil. It's, I think, important to keep our eyes in the medium to long run requirements and understand what is at stake. So I'm really happy to be here with you this afternoon to do so. A few words about my company to start with. Total Energies is a fully integrated multi-energy company. We have a pretty unique business model because we rely on two pillars. One which remains oil and gas, striving to liquefied natural gas. And the other one relying on integrated power. And the two pillars are basically supporting each other. And this unique business model is supporting a major transformation we are going through, going to net zero by the end of the decade, not of the decade, of going net zero by 2050, together with society, meaning together with energy-intensive industries, including the steel industry, because it requires a massive transformation of the energy mix with a surge of electricity. Because we believe that in order to decarbonize, society will need to electrify. And to demonstrate and illustrate that we are walking the talk, a few figures. I'm certainly not going to comment all of them, but in the upper right corner of the slide, starting from scratch 4 years ago, last year we have generated 40 terawatt hours of electricity, originating from more than 25 gigawatt of installed capacity. And at the end of the decade, we want to generate between 100 to 120 terawatt hours of electricity. And for this, we massively invest an average of $5 billion on an annual basis. This is for low carbon energies, low carbon solutions, and 3.5 to 4 solely dedicated to develop our portfolio of renewable assets, renewable electricity assets. And as I mentioned, we do so not standing alone, but we want to do that together with energy-intensive industries. So we have set up a new organization to which I belong called One B2B Solutions. We are organized by industry sectors, including metals. I follow metals globally, steel and aluminum. And our role is basically to understand the decarbonization roadmap of energy-intensive industries and make sure that internally we develop the right solutions, sometimes customize the right solutions to be ready in the right geographies, at the right timing, and as affordable as possible. So, regarding the solutions, obviously electricity is cornerstone, as I mentioned, but we know that there are limitations to electrification. It can be a technical limitation, it can be a question of affordability. So this is why we believe that we need to work also on scope 1 solutions, how to substitute natural gas or other fossil fuels using green gases. It can be low carbon hydrogen, it can be biogas, but as we've understood, nowadays in Europe, for the steel industry, this is not yet affordable. For an industry which is fully exposed to international markets that cannot afford to pay a significant premium. And this is why we'll also work on offsetting technologies. It's not an energy by itself, but it is a low carbon solution that allows to abate CO2, namely carbon capture and storage, on which we capitalize a lot to abate scope 1 emissions. So zooming in a few minutes on renewables, on renewable electricity. You understood 100 gigawatt of installed capacity by the end of the decade, but this slide is more there to illustrate that we are developing a diverse portfolio in terms of technology, a good blend, a good mix of solar, of offshore wind, onshore wind, including some flexibility assets. BESS stands for Battery Energy Storage System, which is extremely important to tackle what is probably the most challenging difference of renewables compared to the current way we are producing electricity, namely the intermittency of renewables. There is a real mismatch between supply and demand, and most of the renewable assets do not produce electricity all the time. Industrial players would like to run their assets, if we take as an example an electric arc furnace, for instance. So there are ways to convert what we used to call the pay-as-produced PPAs, power purchase agreements, the first contracts, where the balancing risk lies 100% on the shoulders of the off-taker, to something where the risk is swapped to the supplier, namely what we call internally clean firm power, being able to supply electricity from renewable sources with a base load shape, or at least a predefined shape. So as I said, on one hand, you try to diversify your portfolio in terms of technology, but you do so also in terms of geographies. You don't want all your assets to be located at the same place, where sometimes there is no wind and no sun at the same time. And you complement your renewable portfolio with flexible assets. I mentioned the batteries, but I need to mention as well CCGTs. You need nowadays gas-fired power plant to be able to balance this intermittency, intrinsic intermittency of renewables. And to finish with, certainly not the least important solution, I mentioned CCS. So you see that we are developing quite an extensive portfolio of storage capacities in the North Sea, in Europe. Storage is basically an oil and gas topic. This is what we can do, and this is why we invest a lot to develop 10 million tons of annual capacity by the end of the decade. And obviously, the capture side must be under the responsibility of the emitter. What we need to work together is to fill the gap in between storage and emission, and develop together the midstream in order to find ways to move the CO2 from where it is emitted to where it will be stored. And this takes time. It's basically the development of a new industry, but in order to do so, we need to start discussing as soon as possible. But in terms of storage, this is commercially operational. Northern Lights off the coast of Norway has started commercial operation last summer. So this is real. We are in Europe storing CO2 underground for a very long period of time. So that was food for thoughts, and I'm looking forward for the upcoming discussion. Thank you.
Yeah, thank you, Christian, for this insight also regarding CCU, CCS. We will come back to that. And with that, it's my pleasure to introduce Francisco Lavaron. He's an industrial engineer with more than 25 years of experience in regulatory affairs, energy policy, and prospective analysis. He has served as representative in initiatives such as the Energy Transition Commission, the Oxford Institute for Energy Studies, Seal Zero, and also the First Movers Coalition. He is also in liaison with the International Energy Agency. So I think a perfect contribution for this panel. The floor is yours, please.
Thank you for your kind introduction, and thank you for the organizers for inviting me. For me, of course, it's a pleasure to be here and explaining why we think that the electricity sector is able to provide the clean electricity that is supposed to be supplying in the next decades. So first, if you don't know Iberdrola, so we are an electricity company based in Madrid. Based here in Bilbao, but I'm based in Madrid. So I think that now we are the first European electricity company by market capitalization. We have activities in Spain, UK, in US, Brazil, and in other countries. We were probably the first large electricity company that started to invest heavily in renewable electricity. And this is probably why we have, in the last 2 decades, a history of success. So, first of all, we have talked a little bit of electrification. I would like to put some numbers. The first thing is that electrification is going to happen everywhere. In China is happening already. They are improving or increasing a lot the share of electricity in their economy. But other regions, including OECD countries or India, are going to see more or less the same process. So for you to have an idea, this is a scenario from the International Energy Agencies. This is called the STEPS scenario, so with the policies that we have today. So electricity is expected to grow steadily from now on in the European Union, and in a stronger way in the rest of the world. This is important because since 2008, the electricity consumption in Europe basically declined, and in some countries declined by almost a third. So we are seeing now that we reached the bottom of the electricity demand. And we are seeing also in most of the regions that electricity demand is starting to pick up. Basically because of electrification. So this is in this same scenario, this is the electricity demand split by sectors. So if we see 2035, transport is going to increase a lot. This is probably the largest source of new electricity. Transport sector is going to electrify not just light-duty vehicles or cars, but trucks probably are going to be electrified completely. And also, let's say, short or medium-haul shipping and other modes of transport. Of course, long-haul shipping is not, and of course, air transport is not going to be electrified. Also, another source of an important source of new electricity demand is its industry. Is going to grow from now to 2035 of around 17%. Buildings. Buildings also include data centers, and I wanted to make explicit the figure of data centers, because everybody is talking about data centers, and demand coming from data centers is going to be important, but it's going to be a part of the new demand. So it's not going to be the largest the part of the new demand in Europe. So this is a very important figure that I wanted to explain. This is conceptual. So basically, what it shows is that electricity coming from renewables is going to be cheaper than the one that we have today. So basically, this is the cost of electricity. The yellow line is with today's costs, and the darker line is with, let's say, prospective cost. And also, what we see is that renewables costs are still going down very quickly, so probably this is a quite prudent scenario. So probably reality is going to be lower. So what we see is that in phase A, an electricity system, you start substituting fossil fuels with renewables. As renewables are cheaper, price of electricity will come down, and you don't have to do anything because the amount of renewable electricity in the system is not important. So in phase B, you increase the share of renewables, cost of electricity still will come down until you reach some point that you get the minimum cost of the system. This point could be around 70–80% of renewables in the system, but this is very dependent on the country. For example, it's not the same Spain, India, China, or the UK. Okay? So when you reach this lowest cost point, if you want to increase renewable, price of electricity will go up a little bit. Okay? Also, this will depend on the resources that you have, on the country that you are. So going from 70–80% of renewable electricity to 100% electricity is more expensive. If you want to go from 20–30 to 60–70–80% of electricity is going to be cheaper. So this is what happened in different countries in the last year. So from 2018 to 2024, what we see is that we have already some electricity systems that has arrived to a quite high shares of renewables. I mean, especially Denmark. Denmark is not very relevant in the sense of technology of electricity system because it's very interconnected. Okay, but for example, Germany is a larger system, so especially Ireland. Ireland is an isolated system, and in Ireland they have around 50% of renewable electricity, and it operates quite well. Spain also is an island. We are operating quite well, except for the event that we have in April. But we are not seeing really large problems with these 50% or over 50% of renewable operation. In the UK, they have also over 50%, and they are operating quite well. In terms of costs, this is what we saw in the previous slide. So as you increase the price, the renewable share in the electricity system, prices will decrease. I mean, these figures include all supply costs, including networks, balancing, and renewable electricity. And this is also a quite prudent figure. The idea that we have within Iberdrola is that renewable systems will be cheaper than this. And also you see here that it's not the same, the cost that we are going to have in Spain, UK, China, or India because of the renewable resources that each country has. And we have, as we increase renewables in the system, we have to do changes in the electricity system. First, because as you may know, wind and solar are not synchronous generation, so they don't provide inertia or other services to the system. And also, you don't have wind and solar when you want, so you have to have other ways of storing and balancing the systems. But what is important to understand is that a system with renewables doesn't have a bigger probability to have blackouts. I mean, we have had several blackouts in Europe, in America, in the last decades, and Spain, it was not a good situation, of course, but I mean, the problem was not having 60% of renewables in that moment. As we are seeing, power system based on renewables will be more competitive than a power system based on fossil fuels, especially if you are in the Sunbelt countries like India or Brazil. Spain also is a good sunny country. In wind-heavy countries, you will have, or you will see probably a higher price. Also because the demand between, I mean, the difference in demand between winter and summer is great, and this also puts costs on the system. This is what I said. The last mile of decarbonizing the electricity sector is more expensive. So probably if you reach up to, I don't know, 80, 90% of fossil-free electricity, it's much better to go to other sectors to decarbonize than the electricity sector. This is because the high shares of renewable, but also because high efficiency of electricity. So it's much better to decarbonize with an electric vehicle or with a heat pump than trying to reach 100% of carbon-free electricity in the power sector. Another issue that is really, really important is to extract all the flexibility that the demand can provide. This today is basically negligible. I mean, and demand has to see and has incentives to be flexible and to provide those services to the system, because here there is a huge potential. And the last thing is grid expansion. I mean, it's not just a matter of building renewables, but also a matter of, moving the renewable from the generation side to the consumers. And strategic planning also. I mean, all this infrastructure is very lengthy to build. And if you want to have, I don't know, some power generation on the grids, in 2035 you have to start building today. So challenges, supply chain. This is a big challenge now. Some parts of the electricity sector, the supply chain is quite tight, especially, for example, cable, transformers. If you see, for example, in the US, turbines for combined cycles are also very, very difficult to get new ones. Social acceptance is very important for us, for building a new infrastructure in terms of renewable and grids. That you have to deal also with local communities that have to accept these new things. Permitting, as I said, building a transmission line can take 10, 15 years, and this is basically because of permitting. I mean, what is constructing the line is not so lengthy. Regulatory environment, this is also very important. I mean, electricity historically everywhere has been charged with a lot of taxes that are not related to electricity supply. And today we have many taxes, especially in Europe. If you go to the US or China, this is not the case, but in Europe this is a real problem. Business models to have all this infrastructure built, anticipatory and policy-aligned infrastructure planning, and so regulatory environment is also very, very important to have all this in time. And just my last thing is skills. This is something that is happening in most of the sectors, but if you want to install a heat pump or you want to build a power line, one of the problems that we have is that we have enough skilled people to do it. Thank you very much.
Yeah, thank you very much, Francisco, for summarizing these challenges and also bringing the topic of skilled people, which is also, in my point of view, a very important one. And I would like to hand over the floor to Michaela, who is with GE Vernova, where she has contributed to different strategies for offshore wind, renewable hydrogen, and microgrid solution. Before joining GE Vernova, she launched the offshore wind program at Gamesa and led marketing and business development for its joint venture with Areva, following roles at ArcelorMittal and in management consulting. We are looking forward to have your input and perspective. Please.
So, buenas tardes. And first, I'd like to thank the organizers and you for inviting us to participate on this panel at this very important event. As you've mentioned, I'm here representing GE Vernova. And I'll start with a little introduction, because I think a lot of people are probably familiar with the GE logo, maybe a little less so with Vernova, the world's oldest startup. We started operating independently in early 2024, and we're trading as an independent company since April 2024. Today, what we have is 75,000 people who are fully focused on electrifying and decarbonizing the world's energy needs. Our equipment is generating about 25% of the world's electricity. So I make it easy and I say, show me the fuel, we know how to convert it into electricity. Our technology generates electricity, transmits electricity, distributes electricity, and applies electricity, as well as stores electricity. We also have digital systems to orchestrate the grid and also to assure that you can operate in islanded mode, for example, as a big steel plant. What we're trying to do is we have our talent that are working with our customers in trying to assure reliable, affordable, and decarbonized electricity so that our economies and our societies can thrive. That means we have brought forward some breakthrough technologies. For example, the first wind turbine blade passed 100 meters, the first small modular nuclear reactors that have been developed and commercialized in the Western Hemisphere. We have the biggest fleet of combustion turbines that are combusting hydrogen. We've brought forward carbon capture solutions for our customers who continue to combust fossil fuels. And we also have just announced our first scale demonstration of our direct air capture. So those are some of the solutions that we're trying to build to the world, we're trying to bring to the world's challenges. And right now, we know that the steel industry is one of the industries, and we've been hearing it all day, that faces a big challenge. I also happen to know, thanks to my background in Arcelor and now in GE Vernova, that the steel industry was thinking about energy transition before that became a trending topic. It's not easy. What's clear to us is that every path to reduce emissions in the steel industry means electrification. And that's where we think maybe we can bring some expertise to the problem. What we're doing is we're leveraging our knowledge of the grid and our knowledge of the electric arc furnace in order to try to safeguard the steel industry. So the electric arc furnace seems to be a winning solution because it's already operating. However, it's not absent of challenges. You need to think in terms of the steel quality, productivity, the sheer size of these electric arc furnaces. We saw earlier how much it might mean in terms of demand that's placed on the grid. And here's a fun fact I learned from my colleagues. From the grid perspective, an electric arc furnace is actually more chaotic than a data center. So this is a challenge. There are new challenges once you bring a lot of electric arc furnaces online in terms of power supply and also power quality. This is what we call a power system challenge, and we like those challenges. That's where we thrive. What we have developed, is what we've tried to do is bring our expertise to this challenge so that we can bring forward efficient and sustainable steel industry. We have developed a patented direct feed technology. So what is this? This is built on proven technology that it's already recognized, and we've already deployed it in the grid. And we've also used it at electric arc furnaces in order to reduce the flicker. It is built around a medium voltage MMC, so that's a multi-level modular converter. And what we have is we have coupled an active front-end rectifier with an MMC converter. So what we achieve with this is that you're going to control that electron. You're going to connect the electric arc furnace directly to the grid. And you're going to control the electron from the grid right into the steel process. So what are some of the benefits that we see? You're going to get a smoother power flow. Because you're controlling the current right through to the steel process, what you can do is you can decouple the electric arc furnace's operation from the grid. That means that you're not going to face grid penalties because you're not going to cause any disturbance on the grid. On the other end, what you're getting is a more efficient steel process. So we think that this is maybe a winning solution. And I'm going to tell everybody I am not an engineer, so please do not ask me detailed questions about this slide. However, even I am capable of seeing what happens when we turned on our direct feed. This is not just a concept. This is something that we have already deployed. It is the first solution that is running on an electric arc furnace of more than 100 megawatts full time. And without understanding exactly what is total harmonic distortion, or whether or not you're meeting certain parameters per the IEEE, what you can see is what happens after we turn it on. That's what the grid sees. And what you don't see on this slide, or what the grid does not see, to put it better, what you don't see on this slide are some of the benefits for the actual steel process. As I mentioned earlier, because you can decouple the electric arc furnace's operation from the grid, what you're doing is you're controlling the current right into the process. The electric arc furnace is no longer limited by the grid parameters. So it can operate at the maximum set point that the steelmaker decides to define. This is going to bring benefits in terms of your productivity. And this allows you to optimize, for example, tap to tap. Okay. So I'm going to wrap there. And what I wanted to explain was we feel like you don't need to choose between decarbonization, solving the world's energy needs, and industry, right? What we can do is we can bring people who know about the steel industry and people who know about the grid industry together to design the solutions that are going to safeguard this industry moving forward.
Yeah, thank you, Michaela, for your insights and technology developments from your side. And last but not least, it's a pleasure to introduce Thomas Kimberger, who is a colleague of mine at the Technical University of Leoben. And in his research and teaching, he mainly focuses on issues aimed at optimizing the efficiency and flexibility of public energy systems and industrial energy systems by means of interdisciplinary systematic approaches. Thomas, please, we are looking forward to your contribution today.
Susanne, thanks for that kind introduction. Yeah, thanks to be here again, speaking in front of that tremendous floor. There is a lot of challenges in that industry. Here you're gonna see those challenges in a nutshell. The question is how to get from roughly 2 billion of not so climate neutral tons of steel production today into a world where we have only clean steel in roughly 25 years or so. Yeah? And this transformation actually stands on 3 pillars. This is something that we know already since quite many years. The first pillar is, of course, recycling steel, electric arc furnaces. This is something which is going on all over the globe, and I'm super proud to say that my Austrian colleagues from First Alpine are doing very good in that regard, really building EAFs. This is a thing that goes on all over the globe. The second pillar is carbon capture and storage. This is, I would say, mainly, but not exclusively, an American thing. This goes on, I would say, more on that region of the world. The second pillar is hydrogen, direct reduced iron for the production of primary steel. This is, I guess, where we guys in Europe mostly focus on, but also in Asia. And I would like to concentrate on that part of that story. I would say the first question is, so when we speak about hydrogen steel, do we have enough resources, renewable resources in Europe to go for that venture? And the question is easy to be answered, and we know that, of course, since quite a while. No, there is not enough renewable resources in our European area. So Europe is super densely populated. We use every square meter of land that we have for some certain purposes, and when we want to build up renewables, it's always a question of to get this done. And we all know the discussions around new wind installations, new PV installations. The grids, they are rather full, so to say, and I would say other regions in the world, they have better so to say, conditions for building up renewables. So at the end, we will need to have hydrogen-based imports to Europe to decarbonize the steel industry, but not only, it's also the question how to get rid of the problems that we have in the chemical industry, which are, I would say, similar than what we see here in the steel industry. And also we need some hydrogen, I guess, for aviation. We will need some hydrogen for running power plants when there is no wind blowing or no sun shining. And this all will not work out with our resources that we have in Europe. So there is the need for hydrogen imports, and we know that already since some years. And we also know that when we speak about pure hydrogen, that it will come over a pipeline network, because all the other options, converting hydrogen to something, reconverting it back to hydrogen is too expensive. And we also know since quite some years that we need to have a comprehensive hydrogen network. And there is good plans, I would say, which we have developed in the last years, how such a core network may look like. And I would say also there is good financing concepts in the shelf. Some countries, they are further, some not so far. The friends in Germany, they have, as far as I know, already a hydrogen concrete financial law in place, which is pretty far. So we guys in Austria, we have quite some good ideas how such a hydrogen concrete may looks like. We also know that most of it is to be composed out of the CH4 lines we already have in place, and which lack in traffic nowadays, since there is no traffic coming in from Russia. So the operators of those grids, they are urging for solutions. Yeah, it's not only the grid-based hydrogen, it's also hydrogen which comes in the form of hydrogen carriers. This is also what we have heard so far. For iron and steel industry, this means hot briquette iron. Hot briquette iron can be an option to help for the production of low carbon steel here in Europe. It's also a bit of a threat because when separating iron making and steel making, question is why not making everything in those places where there is good conditions for iron making. So I would say here the last word is not spoken so far, but it will be. This is my perspective, kind of a mixture. So no news, so to say. So this is all something which we should know since I would say some 3 to 5 years. What there is new is I would say this here. So we have done at my chair we have done some comprehensive calculation how it is with the costs of hydrogen production compared to the prices of CH4, and we have seen that there is cost parity. Someday, natural gas compared to hydrogen, even when natural gas is not getting more expensive in terms of energy costs. Natural gas will get more expensive due to CO2 certificates. We have the ETS in place in the European Union, and this will make hydrogen more, not hydrogen, natural gas more expensive in the future, even when we have low energy prices. Yeah, and there is, as you can see, a nice break-even point between hydrogen and natural gas, somewhere in between 2035 and 2045, when, and this is the statement, when hydrogen production starts to scale. And what we have not seen in the last 5 years was scaling. So when we see where typical green hydrogen projects are now, then they are somewhere in that range of 20 euro cents per kilowatt hour of hydrogen, which is roughly some 6 euros per kilogram. So actually hydrogen production has become more expensive than it has been some 5 years ago. Why? Because we had challenging situations in many industries which led to the lack of investment. We have seen general inflation, which led to higher capex of electrolysis projects, and we have seen actually high requirements. This is also what we have heard before in terms of hydrogen certification coming from EU level, additionality and time coincidence things, which made it really hard to get power purchase agreements for those early stage hydrogen projects. And the question is now how to come out of this gap. So this is what we see right now. We actually know what to do and how to come. And what to do to get low emission steel, and the question is now how to come out. Of course, I don't have the full solution, but what I would like to tell you is actually, or what I would like to bring into that discussion, is that I'm going to see this as a 3 levels approach. First is incentivization of R&D demonstrators by the help of the governments. Second is less strictness when it comes to power purchase agreements, especially for those early stage installations. And the third thing, which I consider actually as the most important one, is to have a better dialogue with the off-takers of the products, so to say. I see out of international discussions more movement in other markets, North America, for instance, to pay for that gap, what clean hydrogen product cost more. We have seen that they are more costly than the conventional way to produce steel. And here the question is, why don't we speak more intensively with the customers which have maybe more willingness to pay? I'm going to speak in automotive, of customers coming out of automotive industry. We have learned before that there is a lot of BMWs, SUVs running on battery electric drivetrains, and maybe those customers, they can pay, I don't know, some €1,000 more to get a stamp somewhere on the car that it is built out of pure hydrogen steel. When we speak about green infrastructures like wind turbines, etc., there is maybe also this kind of willingness. My question would be, what do we need to get those customers a bit better on board to speed up energy transition? Thank you.
Yeah, thank you, Thomas, also for bringing some critical aspects into the discussion. And with that, let's dive into the Q&A session. Following up the panel in the morning where we heard about the projects which are being planned, which are already being realized, maybe starting with a question to you, Christian. Do you have an overview or a number? What is the demand of steel makers in terms of electricity supply need, and what you consider, in your perspective, the most challenging aspect in this system?
I think indeed, Suzanne, it's a key question. Understanding and scoping the demand of the off-taker is obviously something very important. Steel makers have been sourcing electricity for a long time, sometimes massive amounts, especially those operating electric arc furnaces. But switching to renewables leads to a set of differences that needs to be tackled and understood in order to make sure that's done properly. And one of them, for example, is the tenure of the contract. Very often the tenure is very long, way beyond 5 years, which is beyond the liquidity horizon of the markets. It can be 10 years, it can be 15 years, which means that when you sign a power purchase agreement, it's like a wedding. I mean, you don't engage in the very long term if you don't trust, if you don't know your partner. So that's one very important thing. And once you engage into that relationship, you need to make sure you understand what you want and that your partner understands what is needed. And I can give a few examples. Everybody speaks about renewable electricity. But what is renewable electricity? Of course, it's electricity which arises from a renewable asset. But do you want this asset to be additional, as it is required for green hydrogen, for example? Do you want to rely on a portfolio of what we call brownfield assets, which are assets which have been producing electricity for some time, probably coming out of a subsidy scheme? Do you just want to buy guarantees of origin from the market? All this needs to be listed, discussed, and fully understood. And you need also to go one step beyond the sole supply of electricity. We've been speaking a little bit about the balancing and the risk of balancing. The first PPAs were pay as produced, which means that the off-taker was basically carrying the full balancing risk in the relationship. This can be swapped. It can be converted from a pay-as-produced to a clean firm power. You need also to integrate flexibility into your contract. I'm coming from the industrial branch of TotalEnergies, from refining and chemicals. So as an industrial guy, I want my asset to run full blast, make products and please my customers. Nowadays, you need to keep into account that in this new electricity market, not producing can create value, and this is counterintuitive for industrial people. You need to leverage the potential, the flexibility potential of your assets. We understood that the grid has difficulties to accommodate and to balance supply and demand. So being able to stop your plant for a certain amount of time and very quickly has value. And all this needs to be discussed with your supplier.
I think that's a very important perspective from that side as well. Maybe following on with Francisco, you showed the electricity demand for the different sectors and also for the years expected in 2035, 2050. Considering the recommendations you mentioned in your presentation, what would be, in your point of view, the key of supplying enough green renewable energy and clean energy for the future?
I mean, it's difficult to choose 2, 3, 4, whatever. I mean, I'm going to say 3. I mean, the first one probably is awareness. I mean, awareness among, let's say, normal people that renewables are needed, that networks are needed, and we have to invest, and they have to see new infrastructure that today they don't see. And this is very important to increase acceptability. Awareness also among regulators and policymakers, because they are used in the last 20, 25 years to electricity sector going down and not much new infrastructure needed. And now they have to change their mind. Regulation has been focused in the last decades on efficiency, efficiency, and efficiency. And now they have to be focused on efficiency, but also on growth. And this is something that is not easy, because they want to I mean, not let electricity price or tariffs go up. And you can do that investing at the same time. And this, I think that sometimes is not very clear. The second thing is, what I'm talking about is infrastructure. So building this type of infrastructure takes a long time, especially for networks. And we need regulators to plan in advance. because if you need electricity with, I don't know, with high capacity in a place for a steel plant or whatever, this has to be planned with many years in advance. And this is something that is not done usually, especially in Europe. And this is true for steel, this is true for transport, and this is true for everything. And also regulators have to make business models viable for investments. And this is something that happens in some places, and in other places it doesn't happen. So, for example, we are quite happy with the regulation for distribution for networks in the UK and the US, but in Spain is not so friendly. And the last thing I wanted to touch is skills. This is a big problem in many sectors. We are seeing, as I said before, if you want to install a heat pump, you don't find people. If you want to do the engineering of, I don't know, a hydrogen plant, it's not easy to find. And building all this capacity, one of the problems that we have in Europe, for example, with nuclear is skills. And if we want to build up this type of skills, it doesn't happen in 5 years. So it's a question of education system and all the training in the companies.
Yes, that's right. Maybe following one question from the audience to Greg regarding also your slides and your discussion points. I just read the question. Why are you considering that the energy share in the cost stacking stay fixed in order to define a possible prime for hydrogen-based steel making? Why not sharing or reducing such a prime from the electricity price? Many of the hydrogen promoters are electricity producers or part of a joint venture at the same time.
On that graph, it didn't show that we are considering a fixed electricity price. What we are just showing what is the impact of electricity price sourced with a PF-produced PPA on the cost of steel, right? So it was a certain fixed bar on the whole graph, but that doesn't mean that it needs to be fixed. We fully understand that there are some ways of electrolyzer manufacturers to try to lower the overall cost of electricity. I mean, you can have a PPA that's bigger than your electricity needs and then sell over capacity on the market, buy it when the prices are lower. So there are multiple possibilities for optimizing cost of electricity in renewable hydrogen production. The problem still is the regulatory framework. I mean, it was said that flexibility should be valued, right? I fully agree with that. And electrolyzers are fully flexible asset. They can ramp up and down quite easily and fast. But if you are putting the electrolyzer operator on this kind of straight jacket almost, that they need to follow renewables that they have contracted to an hour, then they cannot offer that flexibility on the market, because the moment they ramp down, they cannot buy that electricity from the market at a later stage and still claim it's renewable, right? So if they ramp down, they don't only lose production output, they also lose the renewable kind of characteristic of the produced hydrogen, and that should be changed, right? I mean, Francesco mentioned grid tariffs and kind of infrastructure. That's also a huge important element in the cost of hydrogen production, especially if you are grid connected. And there is also plenty of room on improvement there in terms of costs. We are talking more and more about having dynamic network tariffs to incentivize taking electricity from the grid where it's beneficial for the system and not just running at full load. But then we end up in the same situation. How can I take electricity from the grid where it could make sense from the grid stability point of view? If I take that electricity and I have no possibility of claiming that the hydrogen produced from the electricity was renewable. I cannot even say that it was low carbon. It's basically grid electricity carbon intensity that I need to attach to it. Anytime I take electricity from the grid at a time that's not matched with the renewable energy production time, and even when it's beneficial to the grid. So those rules that are in place really are making those kind of optimization in terms of electricity trading outside of just hydrogen production and the whole interaction between sector coupling in this case, right? Much more difficult than it could have been. And that's why those costs are as high as they are.
And what do you think how you mentioned it shortly in your presentation, the regulatory framework as it is can accelerate maybe also these developments, and what is the duty maybe even for this report?
It would accelerate if it would be simplified. I mean, I fully agree with all those kind of, in principle, the regulatory framework makes sense. It incentivizes use of actual renewable electricity, right? That's fine. However, because of the inflexibility of demand in this case, when we're talking about steel sector, we need to also accommodate the fact that there isn't enough renewable electricity that's available at full load at a reasonable price. So what we should do, we should make that rules easy at the start, and then progressively, once we have that scale up, and it was also mentioned that scale up is needed to bring the costs down, right? So first we should create a framework that would facilitate the scale up of the industry, and then once we are sure that there are enough renewables at a reasonable price, there is infrastructure in place, there is storage in place, then you can progressively turn the screw on the industry and require them to be a bit more and more clean, let's say, and not do it the other way around, because we won't see those projects, we won't see the scale up, the costs will not fall down, and not much will happen in the hydrogen sphere. But that's only one element, right? The improvement of the regulatory framework. The second is also what was mentioned about the creating a demand for those products, right? We mentioned the automotive sector. There are plenty of other sectors that, if there is a way to find to create an incentive for the end consumer to pay for that green steel, not the immediate customer of the steel plant, because for him it's still millions of euro extra cost. But for the end consumer at the end of the value chain, for him, paying for a car that's made from green steel, he wouldn't even notice that, right? But the challenge is obviously to try to create either an incentive on the end user or some incentive for the automotive sector to make it possible. I mean, we are now discussing that we have, CO2 standards that the OEM needs to meet, and it's a problem for them, and maybe you should put those standards further. But why not, for example, create a credit system that if a car is made from green steel, you have a much more relaxed CO2 standard that you need to meet, right? So there are ways of maybe trying to do some innovative, out-of-the-box thinking to create that demand on the market on clean steel products, and then that, green premium of 25%, that could make a world of difference.
Yes, I think, Thomas, you already, or there are many points which you addressed as well. So in your point of view, these are the to-dos we have to tackle, or?
Yeah, I would say yes, and we must come out of this deadlock of only looking on costs. Yeah. So today, this green steel, low carbon steel debate is very much cost driven. So this is exactly what Gregor showed before. Yeah, there is the cost for electricity, then there is all the CapEx thing, and on the other hand side, there is the gray or black steel production, which is not so costly, and then this is very often the end of the debate, and we must come more to a perspective which is on de-risking such projects. Yeah, it's not on the costs only; it's on the risk management of such projects. And I would say there is new levers which can be used to get more projects into that scaling phase. And there is, of course, on the one hand side, all of those regulatory aspects, and I fully agree with you, this is not so cool as it runs nowadays in the European Union. It's too strict, and we have to have a regulatory regime which helps to speed up such projects. But on the other hand side, we share the same opinion on that. There is this end customer willingness, and here I think there is quite some opportunities to come to new collaborations to create some like new and fancy markets, and in this environment where I grew up, where I learned the basics of innovation management, it's not on costs only, it's on handling risks, and there is opportunities, I would say, here in that field.
Yeah, absolutely. Michaela, you showed your innovative solutions for some aspects. So, for example, the direct feed for the electric arc furnace. We already heard grid stability as an important aspect, industrial efficiency. How your technology, whatever, meets these combination of aspects, and maybe also adding a specific question from the audience, not directly addressed to you, but as a general one, more specific, how to measure and balance all the energy data sources dynamically. Yeah, so how to measure and balance all the energy data sources also dynamically. Yeah, so how fast you can react on different aspects in this field.
Okay. So firstly, I'll take the first part of the question, and I found it interesting that amongst the panel members, I think more than one person talked about collaboration, right? And you picked up on something that I mentioned, which was innovation. And that doesn't happen without collaboration, right? So I would say the first thing that's really important is that you need to have all the actors in the room, right? So if it's about regulation, you want to have the policymakers, you want to have the generators of electricity, the system operators, and then you want to have the electro-intense industry like the steel industry in the room. And my suggestion is pull in also the technology providers, because maybe we have some ideas. And we can bring what we know on both ends. So that's one thing. You mentioned innovation. Not your second question was?
Regarding the dynamic data management you
Okay.
collect from your device, for example.
Yeah, so you mentioned stability, and
Yes.
what's clear is we're moving into a world where we are more aware of the fact that we just assumed the grid was going to keep operating. And we are, fundamentally shifting what we're asking the grid to do versus what it was designed to do. So I think we're entering a world where stability is going to become a topic that either you provide stability or you pay because somebody is providing that stability for you. What we tried to demonstrate is a technology that we were able to design meeting both the needs of the industry and the needs of grid stability, right? So, and that also ties in to this idea of dynamic response, because if you have the right technology, then you can have this very fast reacting dynamic response. You can build in some redundancy so you can ride through, and and it doesn't have to impact your process, right? So you can see these benefits on the both sides. And in terms of, I think then we go way beyond when we talk about how you gather all the data points. So there's the data points within the steel plant, obviously, but then you get into the entire system, and luckily we're in a digitized world. So it's not impossible, and in fact, the solutions are out there too, right? It's about how do we blend them intelligently, okay? How do we combine them so you can have different technology solutions that are existing in different applications of electricity, and then you need a system that knows how to orchestrate them. You need a system where you can have plants that are providing dynamic demand response and adjusting to something that's happening on the grid. You have areas of the grid that you can control as a zone so it can operate autonomously, even if there is an incident somewhere in the grid, and then you have your overriding system that sees that all happening. It sounds dreamlike, but we are in a digitized world, and it's like I said, for example, this was a theory a few years ago, but now we actually have a solution that's up and running, and 100% of the time at more than 100 megawatts. It's the same thing with these digital solutions that are out there and are already being deployed. So that's the good news. The technology is there, we need to know how to use it, and we need to get everybody talking to each other.
Exactly, yeah. So time flies. However, I would like to ask one final question. We have heard about innovation, we have heard about technologies, we have heard about the different challenges and risks, and we also stressed the topic of skilled people So I think that's a very important aspect and not so easy to tackle if you open your newspaper on a daily basis to find young, motivated people who want to help or to support all these initiatives. So what should be the message in your point of view to really strengthen this bond? We also mentioned sector coupling, joining forces of different sectors from energy, raw materials, steel industry, and so on. So how can we keep young, motivated, that's really important? Because the way we have to go, I think there is no alternative. We have to go. So what is important that they know?
Does that go to me? To who?
Whoever would like.
Let me start.
Yes.
Actually, this is our day-to-day work, right?
Right.
To motivate young engineers to tackle all those challenges. And the challenges, they are enormous, of course. And actually, the engineering job is not so attractive. So when you look on the enrollment numbers all over Europe, at least, they are going down, and I'm really afraid that at the end this is, all pensioners, this is I would say actually the main challenge of all of that, so that we are running out of engineering skills, and I don't know what a good tactic is to attract this challenge, or to make this challenge more attractive. I think that the younger generation is not always believing us, because they feel that all what we are claiming to do is a bit of kind of greenwashing, because we stick too much on the old fashionable way to do business, and here we have to. And here we have to show them, I think, that we are honestly and with big strengths working on that challenges. And this, I think, we can do the best, showing them real-life projects and real-life approaches. This would be my answer to a really, really challenging question. Much more challenging than all of those technical things we are, I think, good. But this, I think it's critical. Yeah.
And as a complement, maybe Thomas, you're speaking about engineers, that's very important, but I think it's important also to attract the younger generation to technical jobs. We are involved in offshore wind. In order to build an offshore turbine, you need a foundation.
Same story.
One monopile is 1,000 tons of steel, and you know that it's made with thick, heavy plates, very wide, and you need to weld those plates to make the monopile. There is not enough welders in Europe for the projects which are in the pipeline. So there is a real issue beyond only engineering. It's an attractiveness of technical jobs widely.
Yeah, I think there we all share the same opinion, that that's very important and that we have to go further. I think we could go on with our discussion for even longer, because we, as expected, did not have found the overall solution for the questions ahead. But anyhow, it's time for a networking break. Thanks again to all panelists for joining this very interesting and vivid discussion. Thanks to the audience, and if there arise some questions, I think everybody will be available also in the break afterwards. Thank you again. Thank you very much.
Let's get it, Casper.